डिपार्टमेंट ऑफ केमिस्ट्री, गवर्नमेंट डूंगर कॉलेज बीकानेर। आज हम M.Sc. फाइनल के फिजिकल स्पेशल पेपर के तहत जो 9th पे है कंप्यूटेशनल केमिस्ट्री में सेमी एम्पिरिकल थ्योरीज के बारे में पढ़ेंगे। इस यूनिट को डिटेल में पढ़ने से पहले हम कंप्यूटेशनल केमिस्ट्री और सेमी एम्पिरिकल मेथड्स को थोड़ा ब्रीफ में पढ़ लेते हैं। Computational chemistry is a branch of chemistry that uses computer simulation to assist in solving chemical problems. It uses method of theoretical chemistry incorporated into efficient computer programs to calculate structures and properties of molecules and solids. It is necessary because apart from relatively recent result concerning the hydrogen molecule ion, the quantum many-body problems cannot be solved analytically, much lesser in closed form, while computational results normally complement the information obtained by chemical experiment. It is widely used in the design of new drugs and materials. Structure, absolute and relative energy, electronic charge density, distribution, dipole and higher multipole moment, vibrational frequency, relative or other spectroscopic quantities, and cross section of collision with other particles. इसके एग्जाम्पल हैं। द कंप्यूटेशनल मेथड रेंज फ्रॉम वेरी अप्रोक्सीमेट टू हायर एक्यूरेट फॉर स्मॉलर सिस्टम ओनली। एब इनिशियो मेथड आर बेस्ड entirely on quantum mechanics and basic physical constants. Other methods are called empirical or semi-empirical because they use additional empirical parameters. Both ab initio and semi-empirical approaches involve approximations. These range from simplified from the first principle equations that are easier or faster to solve to approximation limiting size of the system to fundamental approximation to the underlying equation that are required to achieve any solution to them all. Most ab initio calculation make the bone Oppenheimer approximations which greatly simplifies the underlying Schrödinger equation by assuming that the nuclei remain in place during the calculation. Ab initio method gave exact solution on reducing the number of approximations. It is impossible to eliminate all approximations and residual error inevitable remains. The goal of computational chemistry is to minimize this residual error while keeping to calculation trackable. Semi-empirical philosophy. Hardy-Fock method is a method for approximation for determination of the wave function and the energy of a quantum many-body system in a stationary state. Hardy-Fock theory is impressive as a physical and mathematical construct, but it has several limitations in practical sense. HF calculation without further approximation, even for small systems with small basis set, was a challenging task, but this theory has a potential. Semi-empirical theory is still in widespread use today, not because it competes effectively with more sophisticated theories in terms of accuracy, but because competes effectively for large molecules or an enormous large number of small molecules to be compared at a consistent level only option. Semi-empirical molecular orbital theories fall into two categories. First, those using a Hamiltonian, that is, the sum of one electron terms, for example, Huckel method, one electron theory. Second, those using a Hamiltonian includes two electrons repulsion terms as well as one electron terms, for example, PPP method, two electrons theory. For a non-planar molecules, the simplifying approximation of treating the pi electrons separately is not available, and all valence electron must be considered to be ab initio used from the being and indicates a calculation based on fundamental principle calculations used with the approximation taking psi as an antisymmetricized product of one electron spin orbitals and use a finite basis set. Semi-empirical method use a simpler Hamiltonian than the correct molecular Hamiltonian and use parameters whose values are adjusted to fit experimental data or the result of ab initio calculation. A basis set is a set of functions that is used to represent the electronic wave function in the HF and DF theory is in order to turn the partial differential equation of the model into algebraic equation suitable for efficient implementation on computer. Review of Huckel model. Huckel मॉडल अप्रोक्सीमेशन की लिमिटेड यूटिलिटी है. ये केवल प्लेनर कॉन्जुगेटेड सिस्टम में कंसीडर किए जाते हैं. सिग्मा ऑर्बिटल जो कि मॉलिक्यूलर प्लेन में रिफ्लेक्शन के रेस्पेक्ट में सिमेट्रिक है नेग्लेक्ट किए जाते हैं. ओनली द पाई इलेक्ट्रॉन एंटीसिमेट्रिक विद रेस्पेक्ट टू द मॉलिक्यूलर मिरर प्लेन आर कंसीडर्ड. द ओवरलैप मैट्रिक्स इज टेकन as a unit matrix and a diagonal element of the F matrix is assigned a value of alpha which depend on the atom type of diagonal element are taken either by beta depending on the two atom type or zero conditioned on whether the two atoms are neighbors in connected by the sigma बॉन्ड. यहाँ एफ म्यू ए इज इक्वल टू अल्फा ए है. एफ म्यू ए म्यू बी बीटा ए बी के बराबर होता है जहाँ पर ए और बी नेबर्स एटम है. एफ म्यू ए म्यू बी जीरो होगा यदि ए और बी नेबर्स एटम नहीं है. इनकी एनर्जी कैलकुलेशन करने के लिए हम ये जो लेवल है 1 और 2 ये ऑर्बिटल लेवल है. ऑन डायगोनल एलिमेंट इनकॉर्पोरेट्स द कूलम्ब इंटीग्रल फॉर ईच अदर और जो ऑफ द डायगोनल एलिमेंट्स हैं कंसिस्ट ऑफ द रेजोनेंस इंटीग्रल. इन दिस इंस्टेंस द कॉरस्पॉन्डिंग टू इंटरेक्शन बिटवीन ऑर्बिटल्स ऑफ एन एटम 1 and 2. Atoms are assigned types much as in force field method, that is parameters depend on the nuclear charge and the bond situation. The alpha A and beta AB parameters for atom type A and B are related to the corresponding parameters for atom type A and B are related to the corresponding parameters for sp2 hybridized carbon by means of the dimensionless constant HA and KAB. Alpha A is equal to alpha C plus HA BCC or beta AB is equal to KAB beta C. cc. The carbon parameters alpha c and beta cc are normally just denoted alpha and beta and are rarely assigned numerical values. Simple Huckel theory thus only considers the connectivity of the pi atoms. There is no information about the molecular geometry entering the calculation. For example, whether some bonds are shorter or longer than others or difference in bond angles. एक्सटेंडेड हकल थ्योरी के एनालॉगस सिंपल हकल थ्योरी के लिए भी चार्ज इंटरेक्टिव मेथड है तथा इक्वेशन 3 के द्वारा हम इसे डिनोट करते हैं। एक्सटेंडेड हकल थ्योरी इक्वेशन अल्फा डैश ए इज इक्वल टू अल्फा ए प्लस ओमेगा ब्रैकेट में एन ए माइनस रो ए ब्रैकेट क्लोज बीटा इक्वेशन 4 है, वेयर Na is the number of pi electron involved from a atom. The Huckel method is essential only used theoretical purpose or for very quantitative orbital consideration. It has ability to produce qualitatively correct molecular orbitals involving a computational effort that is within reach of doing by hand.